So one of the things I think is so interesting is that as we've talked about, you know, our system of planets in orbit about our special star called the sun, and it is very special. Actually, what we're finding out is that I would say most stars, actually, if they had a little bit of spin to them, if they're nebula as the star was forming, they also have planets. And so here I'm going to kind of talk about that and just kind of briefly, how do we go about finding that out? Okay, my thing does not want to go forward. There we go. And generally speaking, we can detect planets in orbit around other stars in one of two ways. We can actually see them, okay, which is an amazing thing because they're very small and they're very far away. And oftentimes that star is pretty darn bright, okay? So seeing them directly is kind of a tricky thing, but probably more than likely we're going to actually just kind of indirectly know that they're there. And I'll kind of show you kind of how that works. Okay, so for instance, indirectly knowing that they're there, that the planet is orbiting the star, a distant star. If we were like on a planet somewhere else orbiting a different star and we were looking back at our sun, we actually would see our sun wiggle a little bit. And kind of like this slide and the next slide talks about the reason that our star would our sun would wiggles a little bit is because of the gravitational pull of that large planet, Jupiter, okay? So we can see that in other stars, okay? And so this is kind of showing you kind of the tugs associated with our star, the sun, kind of wiggling around a little bit. So here's the deal though. Let's just say that, again, I'm kind of looking back at our star do a little bit of dance because of Jupiter kind of pulling at it. Okay, let's say that it wasn't what we call a proper motion, but let's say that motion was radial. And so if that motion of the star is radial because it's being kind of tugged and pulled, pushed and pulled by a planet that's in orbit about it, we can actually then use the Doppler effect, which we looked at earlier. Basically, if the star is moving towards us, we're going to see a blue shift. The star moving away from us, we're going to see a red shift. Okay, so that's kind of neat. Indirectly see the wiggle of a star, okay, and everything points to basically it's got a planet orbiting it that's causing it to wiggle. So actually back in 1995, which does not seem that long ago to me, the first extrasolar planet was found. So a planet in orbit about this star. So since 1995, you know, all sorts of breakthroughs in understanding and seeing planets in orbit about other stars. So here's another way that we can indirectly tell that there is a planet orbiting a distant star, and it's an eclipsing transit sort of situation. So basically, you can kind of see this light meter over here. Maybe I'll kind of do it this way. Oops, yeah. Okay, so do you see the planet in orbit about a star? Now picture that planet then coming, crossing the face of that star. Okay, basically then it's kind of got a disk of light from the star that if we're over here is going to be blocked out. And so that's why you kind of see the dip here, okay, for position 3. Okay, actually, if that was a planet inner to us, if that was like Venus, you know, Earth, Venus, the sun, we would call that a transit. Okay, so the light dips down a little bit. And actually over here, as the planet continues to orbit the star, we see as the planet is eclipsed by the star, we also see a smaller dip. Okay, this is when kind of the planet is back behind the star. So with sensitively looking at the light coming from a star, we can see it diminish as this planet goes in front of it, and also diminish as the planet kind of skirts around the back of it. So that's kind of cool. This is a direct detection. I mean, smiley face to everybody who, I mean, what a rush to basically, and this is a star and it's kind of blacked out, you know, we do that a lot with the sun to kind of look around the sun. You blacked out the energy coming from the star. That is a planet. Wouldn't that be a rush? Okay. So what do those planets, what are those planets in orbit about other stars? How do they compare to our planets? So you're going to see a figure here that kind of like a scatter plot that says characteristics of these extrasolar planets. But when we look at characteristics, one of the things we're looking at is how long does it take to orbit its star? What's the distance between the planets and its star? Okay, what sort of shape or eccentricity is the orbit? How massive is the planet? Okay, what sort of density does it have? Okay, and actually its density kind of tells us if it's a gaseous or terrestrial planet. Down here, my little note to self is actually we have a space telescope that has been dedicated for years. It's a space telescope in outer space, and it's actually just looking at stars and trying to detect planets in orbit about them. I'm pretty sure that Kepler is no longer active, but there's plenty of data that scientists are still mulling through. So here's the scatter plot I talked about. So kind of the relative size of the dot tells you how big the planet, these are extrasolar planets are, how big the planet is relative to Jupiter. Down here in green, I don't know if you can see it, but this figure is in your textbook. Down here in green are the planets of our solar system. Okay. Now there are a lot more bigger dots than there are little dots, and let's see, I've kind of heard the debate, is that because it's easier to see those gas giants than it is to see the rocky terrestrial small planets? That could be. Yeah. So I mentioned that there are more gas giants out there than there are rocky terrestrial planets. So it's kind of out there. Now this is a little bit dated. Gosh, I think this is like several years old. Okay, but this says more than 1 in 10 stars have turned out to have planets. And I think it's even higher.